2 times the quantity of 3x plus 4 minus 2x equals 10. Okay. So 2 times the quantity of 3x plus 4 minus 2x equals 10. So everyone go ahead and do that problem for me. Hi, Jillian. We just got started. I'm just having them do a little problem here to kind of review while I let you guys all jump on here. So as you guys are working on this problem here, okay, a couple things I noticed when I checked off homework this morning, quite a few of you still had to finish the 1.2. So make sure, or 1.1, make sure you go onto that class link, Big Ideas, and complete the 1.1 and 1.2, okay? Obviously today we're gonna get a 1.3 since that's what we're learning today. So make sure you have at least 1.1, 1.2, and 1.3 done by Monday, because what does Monday mean? It's an 8-block day, so what will we have? We'll have a short quiz. We'll have a shortened day, but we're also gonna have a short quiz, okay? So your quiz on Monday will be over 1.1, 1.2, 1.3, so make sure you go through those problems. If you have questions, you let me know, okay? All right, so as we have this problem of 2 times the quantity of 3x plus 4 minus 2x equals 10, what would be my first step here? Go ahead. Yeah. Good, so I'm gonna distribute the 2 through everything, okay? So which was step 1 here, okay? We distribute. So 2 times 3x is 6x. Okay. 6x. 2 times that positive 4 is 8. Do I distribute the 2 to the 2x? No, because it is not inside the parenthesis. Minus 2x equals 10, okay? Now, step 2 here says we're going to combine what? Like terms, right? We're going to combine like terms. So now we have this 6x and we have this negative 2x. Are they on the same side or different sides? They're on the same side. So if they're on the same side, we're just going to combine them as it says, okay? So what is 6x minus 2x? 4x, good. Then we still have the plus 8 equals 10. Now, what we're going to learn today is when they're on different sides. So I'll fill that here in a second. Okay. Now, after we combine like terms on the same side, okay, we are going to add or subtract what? The constant to the other side. So in this case, my constant is what number? The 8. So how do I move a plus 8 to the other side? Subtract it. So we have 4x equals 10 minus 8 is 2, okay? And then we're gonna multiply and divide by the, it's called the coefficient, right? Coefficient. So we're gonna multiply or divide by the coefficient. And what's my coefficient here? 4. So how do I get rid of the 4? Divide by 4. So 4 divided by 4 cancels out. I'm left with x. And can I divide 2 by 4? But we get a decimal, and I don't like decimals, do I? So what would 2 over 4 simplify to? So x is equal to 2 over 4, which simplifies to 1/2. But so x would equal 1/2. Okay. Now, the one thing we're going to talk about is now today is those variables on different sides. Okay. When you were in middle school, they called them VOBs. Remember that word? VOBs. Okay, so that just means the variables on opposite sides, okay? And the main thing is to combine them, we're always going to do its opposite. Okay, so if it's like a plus 2x on one side and I have to move it to the other side, we're gonna subtract it to the other side, okay? So we do its opposite to move it. Okay, so if it's plus 2x, we would subtract 2x. If it's a minus 2x, I would add it to the other side, okay? So we're going to look at variables when they're on different sides, okay? So let's look at example 1 here. All right. The nice thing about example 1 is we don't have to distribute anything, do we? Nope. But we do have our like terms, right? What are like terms? We have the negative 4x and we have the negative 9x. Okay, are they on the same side or different sides? Different, okay? And it doesn't matter which one we move. I tend to always put variables on this side, okay? So I tend to move everything from the right side to the left side, but it doesn't matter, okay? So if I want to move this negative 9x to the other side, what's the opposite of a negative 9x? Positive 9x. So I'm going to add 9x. Okay. So I have the 10 is going to stay. And what's a negative 4x plus 9x? Positive 5x. Good. Equals negative 9x and positive 9x will cancel out, right? And I'm left with what on that side? 2. Okay. Now my variables are combined. So now we're back to our two-step equation. So am I going to move the 10 or the 5 first? The 10 because it's the constant. And how do I move a positive 10? We're going to make it negative. Subtract it. So 10 minus 10 is 0. So we get 5x. And what's 2 minus 10? Negative 8. Good. And then how do I get rid of the 5? Divide the 5. Now, 5 divided by 5 is 1. So we're left with x. And can I divide negative 8 by 5? No. So we leave it as negative 8 over 5. Don't lose your negatives. And that would be your final answer. All right, let's look at B here. Okay. Now, this one's a little bit different here, okay? And in this case, we have that negative 2x and that 3x, okay? Now, when we only have an x on the one side, even if it was on the right side, we always want to go to where that single x is, okay? So if I have negative 2x, that's the only thing on the left-hand side, I need to move the x to that side, okay? If we had one, say, like 5x plus 2 equals 7x, in this case, this 7x is the only thing on this right side, so I need to move it on that one. That's the only time I move it to the right side, is when that's by itself, that variable is by itself, okay? All right, so if I want to move that 3x, okay, it's positive, so how do I move that positive 3x to the other side? I'm going to minus it, yep. Now, that's negative 2 and negative 3, they're both negative, so I just add the numbers. So it's negative 2 plus negative 3, negative 5x. 3x minus 3x does cancel, and it's a plus 10, so I make sure I bring down a positive 10. Okay. And then how do I get rid of that negative 5? Divide it, perfect. Both sides. So I'm going to get x equals, because a negative divided by negative is a positive 1. And then 10 divided by negative 5 is negative 2. And there you go. Good. Now let's look at D here. What would be my first step here? Distribute. And what am I going to distribute in the first parenthesis? The 3. Right, the 3 to the 3x and the negative 4. And then what am I going to distribute in the second one? That 1/4. Okay. Now let's do the 3 first. What's 3 times 3x? 9x, right? What's 3 times negative 4? Negative 12, good. Now, when we multiply by a fourth, a lot of people don't like multiplying fractions, but all that is you multiply by the numerator, divide by your denominator. Well, if I multiply everything by 1, does anything change? No. So to multiply by 1/4 is actually we're just dividing everything by 4. So what is a fourth of 32? So it's 32 divided by 4. 8x plus, and what's 56 divided by 4? That would be 36. So we're doing 56. So 56 divided by 4. So 4 goes into 5 how many times? once with a remainder of 1, bring down the 6, and then 4 goes into 16 how many times? 4, so it's actually 14. Okay. All right. Now, these x's, 9x and 8x, are they on the same side or different sides? Different. So I'm going to move the 8x to the left side. So how do I move a positive 8x to the other side? Subtract it. So 9x minus 8x is 1x. Do I need to have the 1 in front? Nope. Bring down the minus 12. 8x minus 8x, 0. And then we have equals 14. Okay. Now, solving for this x, how do I move the plus or the minus 12 to the other side? Add it, as I tell you. So x, negative 12 plus 12 is 0. And 14 plus 12 is 26. So x is equal to 26. And then looking at E, okay? Looking at E. So what would I distribute first in E? The 1/2, right? And 1/2 is the same thing as just dividing by 2. So what's a half of 6h? Half of 6 is 3. And a half of negative 4 is negative 2 equals negative 5h plus 1. All right. Now, let's always move the left side to the right side. So we have this negative 5h. So how do I move a negative 5h to the other side? Add it. So what's 3h plus 5h? 8h minus 2 equals a negative 5 plus 5 is 0. So we're equal to 1. All right. Now leaving 8h alone, I need to move the negative 2. So how do I move the negative 2 over? Add it. So 8h equals 1 plus 2 is 3. And then how do I get rid of the 8? Divide by 8. So h equals, now can I divide 3 by 8? No. Do we need a calculator to figure out the decimal? No. We just leave it as 3 over 8. All right. Good job. All right. Part C. Okay. Go ahead and distribute. So everyone go ahead and distribute in part C first on your own. Okay. Anyone at home have questions so far? So either pop up on your screen or say no, type something. Max, I saw you pop in. Do you have any questions? No? Okay.
Nope.
Okay, thank you, Jaden. Anyone else? Tommy, you doing good?
Yeah.
Okay, Summer, you doing good? Maxwell, you doing good?
Yep.
Thank you. Max already answered. Mallory, you doing good, kiddo?
Yeah, I'm fine.
Okay, thank you. Jillian?
I'm good.
Thanks. Gabby?
I'm good, thank you.
Thank you. Ethan? Emma, you good?
Okay.
Okay,
I know
Ethan,
what-
you answered? Oh, no, Max,
No,
I hear
I
you.
can't. Yeah.
Okay. All right. Emma, you good?
Yeah, I'm good.
Okay, thanks. Brayson?
Yeah, I'm good.
Okay. Ava?
I'm good.
Good. Mason?
I'm good.
Okay, did I miss anyone? I don't think so. Yes,
Greg.
if you wanted to. Great, thanks. Thanks,
Greg's
man.
not here.
Huh? I know Greg's not here. I see that. There's a few that aren't here. All right. So when you distribute that, okay, we ended up with what? So 2 times 3x, 6x, and 2 times -4, -8. Go ahead. Now I'm going to go ahead and box my variables because if you notice, we have 3 different variables, don't we now? Okay. So the first thing we do is always do the ones that are on the same side. Okay. So same side, we don't do its opposite, do we? Okay. So what is 3x minus 4x? -1x plus 2 equals 6x minus 8. That's why I kind of draw the line there. Okay. To know if they're on the same side, just combine them. Now, how would I move this 6x over to the other side?
I have a question.
Yes, ma'am.
How'd you get the 3x minus 1x?
So 3x and the -4x got me to that -1x.
Okay, okay.
Okay.
Thank you.
Okay. All right, and then how would we said we're going to subtract the 6x? Okay. So -1x minus 6x is -7x. We have the +2. The 6x's cancel, and we always bring down the -8, the minus with it. Okay. Now, solving for that -7, how do I move that 2 to the other side? Subtract the 2, good. So we have -7x. Now, because these are both negative, it's going to stay negative, and we're going to make it a negative what? 10. And then how do I get rid of the -7? Divide it. So x equals 2 negatives make a positive. So 10/7. Okay. I can't divide it. Now, make sure if you see those 2 negatives, you always make it a positive, okay? All right. And then f here. It's kind of hard to see. I'm going to erase some of this so we can see a little better. There we go. F's got a lot going on a little bit, doesn't it? Just doesn't have some parentheses, but we do have a lot going on. So I'm going to go ahead. I like boxing my variables just because those are the ones I want to combine. Okay. So as I look at it, I have -2 plus 3x minus 4. Do we have any like terms on that left-hand side? Yeah, we have this -2 minus 4. So can I combine those two? Yeah, what is -2 minus 4? -6, good. We have a plus 3x still. On this side, on the right side, left side, sorry, we have some like terms, don't we? So let's combine them. What's 5x minus 2x? 3x. Okay. Now, these 3x's, are they on the same side or different sides? They're on different. So we need to move that 3x to the left side. So how do I move that positive 3x? Minus it. Now we have -6 equals, what's 3x minus 3x? 0. And 0 times anything is 0, right? So what happens to that variable? It's gone, right? We have 10 on this side. What's 3x minus 3x? What's 3x minus 3x again? 0, it's gone. Huh. We don't have a variable here. Oh, sorry, my other one kicked out for some reason. All right, so we don't have a variable. In this case, if there's no variable, we have special cases. Okay, so we're going to talk about that before we actually answer that. Okay, so special cases. Okay, so special cases is when our variables do cancel out. Okay, the first one we're going to talk about is when we have an identity. An identity means the left side is exactly the same as your right side. So no matter what value I throw into x, it's going to be a solution. Because if I have like 1 plus x equals 1 plus x, no matter what I put in for x, wouldn't the left side equal the right side? Yeah. So that would be infinitely many solutions. So if my variable cancels out, just like what we had here, okay? If the constants equal each other, and what are constants again? Just the number without the variable, right? So if 2 equals 2, that means that's a true statement, right? So we would say that has infinitely many solutions, okay? So if I come up here, up here, did -6 equal 10? No. So we wouldn't have infinitely many solutions, okay? So now the next one is this no solution. Again, no solution is when our variables cancel out, but now the constants will not equal each other. Meaning, and no solution means there's no value I could plug into x that would make my equation true. So if I come back up here, our variables canceled out. Does -6 equal 10? No. So in that case, we have no solution. So that answer is no solution. Okay. So now, as we looked at, okay, when we said x equals 10 over 7, that means we had one solution, right? X can only equal 10 over 7 to make the left side equal the right side. In this case, because our variables canceled out and -6 does not equal 10, we have no solution, meaning there's no value for x that would make my left side equal my right side, okay? And infinitely many would be any value I plug in, we're good, okay? They're both gonna equal, all right? So let's look at a couple more examples here. All right, so 3 times the quantity of 5x plus 2 equals 15x. What would be my first step here? Distribute, right? Okay, so 3 times 5x is 15x. 3 times 2 is 6 equals 15x. All right, now we have like terms. On this side, do you see how 15x is the only thing on the right-hand side? I'm gonna move that to that side, okay? Because I don't wanna make it 0, okay? So how would I move a positive 15x over? Minus it. Well, what's 15x minus 15x? 0, so I get 6. What's 15x minus 15x? 0, do you see I have nothing there? We always put a 0, okay? Now, what happened to my variables? They're gone. So the only options we have is this no solution or infinitely many solutions. Does 6 equal 0? No. So this one has to be no solution. So meaning no value I plug in for x would make my left side equal my right side, no matter what. Okay. All right, let's look at B here. What would be my first step in B? I say distribute again, right? So 4 times 1 is 4, and 4 times a negative p is negative 4p. Okay. So now looking at my p's, I have a negative 4p and I have a negative 4p. What do you guys notice about those? They're both negative, and aren't they the exact same? So what's going to happen to them? They're going to cancel out, because if I add the 4p over a negative plus that positive, the same number, doesn't those cancel out? Yeah. So now we have 4 equals 4. Is that a true statement? Yeah. So this one would be infinitely many solutions. And I don't mind if you abbreviate. Okay. So no matter what, if I plug 1 in for p, that left side's going to equal the right side. If I plug in 7 for p, that left side's going to equal the right side. Okay. All right, C, what would be my first step for C? Distribute. So negative 2 times 3y, negative 6y. Negative 2 times 1, negative 2. And we have equals negative 8y minus 2. Now, as I look at my y's, are they the same or different? They're different, right? So will they cancel out? Will they cancel out if they're different? No, they're not going to cancel out. So could we have no solution or infinitely many here? No, we're actually going to have a value for y. So that's one thing you can always determine. If the y's are different there, you're always going to have a solution. So let's move the negative 8y over. So how would I move negative 8y over? I would add it. So it's negative 6y plus 8y. 2y. We have minus 2. Negative 8y plus 8y, that would cancel. We had a minus 2, so I make sure I have a negative 2. And now we keep solving. So how do I move the minus 2 over? Plus 2. So we have 2y, sorry, I'm sliding over, equals, what's a negative 2 plus 2? 0. Now, I still have a y. I'm still going to have the answer, okay? So how do I get rid of that 2? I do. It's pretty darn good, isn't it? All right. Now, what is 0 divided by anything? 0. So y equals 0. So the only value for y to make this equation true is 0. That's it. Okay? 0 is a number. That means y can be 0. All right? All right, and then our last one here. Give a second to think about that. You guys don't like fractions very well, do you? And I gave you one. Yay. Okay, that's all right. It's not too bad. You guys can handle this, okay? So, all right, now remember, to multiply by a fraction, you multiply the numerator and divide by the denominator. So what's 5 times 6? 30, and what's 30 divided by 6? 5. So you just have 5m. That wasn't too bad, was it? Now, 5 times 12 is a little bit harder, right? Does anyone know 5 times 12? Close. 60. And 60 divided by 6 is 10. There you go. You just did it, guys. Was that as bad as you thought? Yeah. No. Still pretty hard. You could have divided first too, and then multiplied. So I could have done 12 divided by 6 is 2, and then 2 times 5 is 10. Okay, so you can either do either way. All right, now let's look at my m's. We got lots of m's. We got 3 of them. 6m minus m. That's on the same side, isn't it? So just subtract it. What's 6m minus m? 5m. Remember, there's a coefficient of 1 in front of m. Equals 5m minus 10. Okay. So now, solving for these m's. Now these m's are on different sides, right? So how do I move a positive 5m over? Subtract it. So 5m minus 5m is 0. There's nothing on this side, so what do I put? 0. 5m minus 5m canceled, but I still have this negative 10, so I got to keep that negative 10. There's no variables. So what are my 2 options? No solution or infinitely many. Does 0 equal negative 10? No. So what's my answer? No solution. Good. And that's it. That's variables on both sides, guys. Okay, so I'm going to go ahead and stop sharing.